Hi guys, you're welcome to my channel. Okay, now today exercise we're going to take a look at wiring your logic program into PLC controller. Okay, now we find out that the most challenging aspect of automation is your ability to carry out your wiring exercise into PLC controller. So I'm going to walk you through the basic concept and the fastest method for you to do that. Okay, now take a look at this portion. This is my induction motors. I have three here. The sequence operation of this particular motor is going to be dependent on this particular logic I have here, and I will download this logic into my PLC. Now, this portion is my input controller, input bit. These are input devices. Then here is going to be my output devices. Because of tight space factors here, so I now have to shift this to this place. Ideally, you're supposed to have this close to this portion because this is my where my input device is going to be terminated. Then my output devices, they are also going to be terminated here, but I don't have enough space here. I now shift the wiring termination down to this place. So the whole of this output belong to this portion here. Then this is the logic that will control the sequence operation of this particular motor. Then, like I said before, this is the input. Then this portion here is what we call HMI control. We have HMI, human machine interface. No, ideally, in an industrial setup, you're supposed to have a control panel, a switchboard. Control panel consists of switches, contactors, MCB, overload, and other integral devices that make up the control panel. But now, in some cases, you find out that the control panel will be situated at a considerable distance from the control room. So because of that, we create what we call an interface control system, you know, which will now interface the starting system between the panel and the CPU and the controller PLC. So in that case, we can now generate what we call HMI. So this is HMI, a kind of HMI mini start station. So I can start here and off here. I can also reset fault here and also introduce a fault from here. So this one is going to be situated right inside the control room. Meanwhile, the panel that encloses the whole of these devices and these other devices may be situated right inside the field, in the field. So that is why I now generate this other starting point. So you can start from here. You can also start from here. Okay, now let's see if we can demonstrate and simulate the operation sequence of this. Then once again, uh, this particular portion is my fault lamp. I have my fault lamp here. Each of these overload, it is presented this particular indicator lamp to indicate and illuminate whenever these other ones trip off, right? You know that this overload, the function of this overload is when there is a friction or when there is a resistance coming from mechanical part of the equipment. That is when this one will respond to fault. Upon that, is going to be subjected to this particular flashlight. I created a flashlight here to show that each of these pump has a fault. Okay, so this other logic here, this section of the logic, they are my output bit. Output bit 1, 2, 3. They are output bit belonging to this contactor, right? They are closing this contactor. Then the whole of this, they are all my input bit representing this as well. So part of this is what I just generated here so that I can start from control room, also reset the fault from control room. So let's now carry out our simulation process. Now I now put on the power here. So this other one are my contactor closing my power to the motor. So let me start the operation. I put on this one will come up. After a few seconds, this one will come up. After a few seconds again, this one will come up. That is the sequence of operation of this. So each of these represent this coil. This pump 1 represent this coil. This pump 2 is having this coil. This pump 3 is also having this coil. They have their indicator lamp respectively that will indicate when each of this motor comes up. Then this is their tripping fault light. If when each of them trip off, the fault light will also indicate from here flashing, right? To alert the operator that each of the motor is having an issue. Okay, let's now start from here. This one is up now. After a few seconds, look at it here. After a few seconds, this one will come up. This one is up now. After a few seconds, this one will come up. All right, this one is up now. Now, supposing there is a fault coming from a mechanical part of the equipment. So let me create a fault by clicking here. Let me click here. If I click here now, this one will flash. This is a flash lamp telling me that there is a fault. If this one generate also a fault the second time, this one will also flash. If this one create a fault again, this one also flash. So how do I reset them? Instead of me going to the field where the panel that encloses here is situated, I can reset it from my control room. So each of these buttons can reset this fault. Let's do that. I reset from here. This one shut down. I reset this one. This one is resetted. I reset this one again. This one is also resetted. So that is the function of this reset button, right? Okay. So you must pay attention to this particular part again. Now, this CPU, let me change the orientation of this. Let me change the orientation of I change it here. Okay, let me change this way. Okay, now take a look at this. I have output of my CPU is comprising only 8 output here. 8 output. But if you take a look at my output here, I have more than 8. I have 9. 1, 2, this is 6, 7, 8, 9. I have 9. Meanwhile, I have 8 here. So it means the only way you can generate multiple output while using limited output from your CPU is to introduce a relay device. Whenever I have something like this and you need more output, and you don't have to buy additional output output module, extension output module here to attach here. If you don't have to buy that, you don't have money to buy that, you can now use relay to interface between one of the output to generate a different sub output. For instance, this is my contactor that is representing this module. I just use this indicator lamp to feed from my contactor. Instead of sending the whole of this lamp to my logic and also send them to my output device. So I can take from the coil to make it faster, right? So that is why you see multiple output using limited output from my controller. All right, so that is what I have to walk you through today. Then the next exercise, we're going to take a look at the logic, how you can write the logic and terminate the logic from such a, like as I just did now. I can write this logic and also modify this logic to add more features, right? To add more features and use that same logic to control a particular industrial process. All right, thank you. Then the next exercise, like I said, we're going to generate the sequential operation of it so that when this one comes up, after a few seconds, this one comes up. After a few seconds again, this one will come up. Then at the last time, this one will come again. Then the cycle will repeat until you de-energize the system. So this is how you can automate a process using PLC S7 1200 model, right? But the most essential part of this exercise is to enable you to understand the wiring connection process, because most students write program, but the termination exercise is what they have not been able to perform on their own, except their instructor guide them through. They cannot work under with themselves, except they are having a close supervision before they can carry out that particular exercise. So take a look at this process of termination and this other one. Like I said before, this particular input bit supposed to be close to this termination process. Then this other one supposed to be here, but we are having a very tight space factor. That's why you see me sending the wires from here to this side. So you can also, like, we can change this to red. The whole of this fault lamp can be red because red is more familiar to fault alarm. So we can change all of them to red so that the red will be flashing when each of the fault arises. All right, thank you. So our next exercise, we continue from writing the program. Thank you.